Today I want to talk about complementary and contrastive distribution in linguistics. So, to begin, what is complementary and contrastive distribution? Well, complementary distribution is when two phones do not occur in the same linguistic environment. In other words, they're mutually exclusive. What this means is that if one phone occurs in one environment, um, the other phone cannot appear in the same environment because the presence of this one phone cancels out the presence of the other phone in the same environment. And since the same phoneme surfaces as different phones, um, the same phoneme or the different phones are allophones of the same phoneme. So, an example would be in English of the phoneme P, which can surface as the aspirated P and the normal P. When a word begins with a P in English, it usually surfaces, it always surfaces as the aspirated P. But in other environments, it surfaces as the normal P. So, for example, when we say pit or pull, there's actually an aspirated P in the beginning. We don't say pit, pull. Well, it's hard to pronounce, but you get the point. However, when it is not in the beginning of the word, such as the examples of speak and spell, we do not see the aspirated P. Additionally, aspiration also occurs in the beginning of a stressed syllable. So, for example, in the word apart, which has two syllables, there's aspiration in part, and the P of part, because it is the beginning of a stressed syllable, apart. So now that we've discussed a little bit about complementary distribution, let's see what contrastive distribution is. So contrastive distribution is, on the other hand, when two different phonemes occur in the same environment, the same linguistic environment. So this difference also creates a different meaning. So again, an example in English would be the P and the B, which are in contrastive variation because the same environment, which I will explain a little bit later, with only the phoneme change of either P or B changes the whole meaning of the word. So, for example, the same environment would be the IT in pit and bit. However, we only change the P and the B here, and it creates two different meanings. Same thing with pair and bear, and so on and so forth. So, in these examples where only one element or the target element changes, is also called a minimal pair because the environment is the same and only the target segment is different. In this example, the target segment would be the P and the B, and everything else stays the same. The whole environment stays the same, which is why they are minimal pairs. So now that we've talked about this, let's look at some spectrograms to see how this would play visually. So here I have a spectrogram of the word pit. So as we can see in this spectrogram, the VOT or voice onset time is illustrated with the blue bar. So VOT is defined as a time between the consonant burst and the voicing onset of the vowel. And it deals with plosive stops, which is what P and B's and all of those are. The red little dot here illustrates the release closure, and the yellow bar represents the voicing onset. But I want to draw the attention to the length of the VOT of the voice onset time in the word pit in the spectrogram, as it is roughly 85 milliseconds. Now, if we look at another example of an aspirated P, we also see here that it's roughly 70, the VOT of a part, which is also aspirated. Now, taking the aspirated P's of pit, the previous example, and a part in this example, and comparing them to a normal unaspirated example, as shown here in speak, we notice that the spectrogram, here we see that the first area here is actually that of the sibilant, and here we have the vowel. But here notice that the P is not an aspirated plosive, So the VOT is much shorter compared to the other two previous examples that I just showed. So let's again visit the spectrogram of the word pit, keeping in mind again the shape of the spectrogram, which I will now compare with the bilabial B shown here. Notice how there's not much change in the spectrogram except for the plosive. So by seeing the visual representation of the spectrogram here, we see that the contrastive distribution of P and B and the surrounding environment is shown. So the surrounding environment, again, does not see much change of this area and this area. But notice how much the target segment here, which is the voiced bilabial B and voiceless bilabial, notice how here's the aspiration and here there is no aspiration, there's nothing. So this is how they would map differently onto the spectrogram. Thank you.